So in this exercise, I basically need to find the volume of this object right here. And this object is a result of the region R right here, rotating 360 degrees around the x-axis. And this region R, as we see here, is bounded between the x-axis, the y-axis, the vertical axis, and here the curve. And we have the equation of this curve. So the first thing we need to do in order to find the volume is know the formula of that. So the volume here is equal to pi times the integral from a to b of the function f of x squared dx, because we're integrating here in respect to the variable x. And so the second thing that we need to do is find a and b. So find the integral boundaries, find a and b. And a and b here is basically where my region starts and where my region ends. So my region starts here at this point, and it is basically where x is equal to 0. So a is basically x is equal to 0. And b here, the region b, is where my region stops, so where r stops, and that is x naught right here. So that is x naught, and we need to find x naught. And in order to do that, we can use algebra. We see here that when we have x naught, we have y is equal to 0. So all we need to do is equate f of x to 0, and we would get x naught. So we have f of x is equal to 0. That means that our function here, e to the power of 0.5x minus 2, is equal to 0. Now we will take this equation right here, and we will solve in respect to x. So here solve in respect to variable x. That would be e to the power of 0.5x is equal to 2. And now in order to get rid of this e, right here, we will have to use the operator ln on both sides of the equation, and both sides because this is an equation. And so we will have ln of e to the power of 0.5x is equal to ln of 2. And ln will cancel with the e, and will give me this exponent as a product or a factor. So I will have 0.5x is equal to ln of 2. And 0.5x is nothing but x over 2 is equal to ln of 2. And I only need to get x, so x here would be 2 times ln of 2. And I can simplify that because this factor right here can be a power to what's inside my logarithm. And that would basically be x is equal to ln 2 to the power of 2, and 2 to the power of 2 is basically just 4. So this is x naught. This is what x naught is equal to. So here, my second integral boundary is basically x naught is equal to ln of 4. Now that I found that, I can just basically make this smaller to have more space to write. Third step now is to actually solve the integral. So now I'll take my formula, that is pi multiplied by my integral. We said a is equal to 0, and b is equal to ln of 4. And now my function here is squared. So my function is basically e to the power of 0.5x. 0.5x is nothing but x over 2 minus 2 squared dx. And we will notice here the binomial form. I need to do the binomial expansion. I'll do that easily right here. I'll have e to the power of x over 2 minus 2 times e to the power of x over 2 minus 2. And so I just need to multiply. So this multiplied by this, e to the power of x over 2 multiplied by e to the power of x over 2. That'll give me e to the power of 2x over 2, which will just basically be x. And then I multiply the rest of the factors with each other. I'll get minus 2 times e to the power of x over 2. And again, minus 2 times e to the power of x over 2. And then plus 4 at the very end. So I simplify this expression right here. I'll get e to the power of x minus 4 times e to the power of x over 2 plus 4. And this is what I have inside my integral right here. So it'll be v, the volume, is equal to pi times my integral boundaries from 0 to ln of 4. And then I'll have what's inside my integral. The function that I need to integrate is basically going to be e to the power of x minus 4 times e to the power of x over 2 plus 4, and then I'm integrating in respect to dx again. So what I can do here now, I can split this integral into 3 integrals right here. Or I can just integrate as if I'm integrating a polynomial. So here, addition or subtraction, just integrating each term separately, the terms that are inside the integral. So here I'll have the volume is equal to pi, and then I integrate this first term right here, e to the power of x, and the integration of that is relatively easy. I'll just have these parentheses to know my boundaries later on to do the subtraction. I'll have the integration of e to the power of x, and that's basically just e to the power of x, minus 4 times e to the power of x over 2, and that will be 4 over 1/2 times e to the power of x over 2. And let's just simplify this term real quick right here. 4 over half is just basically equal to 4 over 1 times 2 over 1. That's going to give me an 8. So here I can just simplify this by writing 8 times e to the power of x over 2, and plus the integration of 4 is going to be 4x. And now I apply my boundaries, 0, and that means I'll have to subtract. So I'll have here v is equal to pi, and I'll pull pi out, so I'll multiply pi with the whole operation of finding the value of the integral, the numerical value, so to say. Now if pi is multiplied by, now I take my first boundary, b, and I substitute for x. So e to the power of ln 4, or I call it ln, but it's ln, whatever, minus 8 times e to the power of ln of 4 over 2 plus 4 times ln of 4. Now I put this whole function for the first boundary inside parentheses minus the second one right here. That's going to be e to the power of 0. I take my second boundary, the lower boundary right here, which is 0, and I substitute it for each x in the equation. So e to the power of 0 minus 8 times e to the power of 0 over 2, which is basically just 0 as well, plus 4 times 0. And I do the subtraction between these two square parentheses, whatever. So that's going to give me the volume, pi times, now e to the power of ln of 4. I'm just going to simplify each expression right here. So e to the power of ln of 4 is just going to give me ln of 4 minus 8 times e to the power of ln of 4 over 2. This is going to give me 8 times 1/2 ln of 4 plus 4 ln of 4.
If you got any unsolved problem in the world of numbers and equations, make sure to comment it down below and we can get it solved.
Third term. And now I take the function from the second boundary, and I'm gonna basically just distribute this negative sign right here across all of them, so that I don't have two parentheses at the same time. So that I only have the square parentheses. So I'm gonna have minus e to the power of 0 plus 8 times e to the power of 0, and then minus 4 times 0. 4 times 0 is 0 anyways, and e to the power of 0, that's just basically going to give me a 1, so here minus 1, and 8 times e to the power of 0, which is 1, is going to be 8 times 1, which is basically just 8. And now I get the like terms together, and all I have to do is write my final answer. So my volume here, pi, is going to be ln of 4, and I can factorize here ln of 4 since it is common in more than one term. So I can say pi right here is distributed across ln of 4 multiplied by, or distributed across, 1 minus 8 times half, which is basically just 4, and then plus 4, and then here minus 1 e plus 8 outside of the parentheses. So I'll have minus 1 plus 8, that's just going to give me plus 7. And here inside my ln function, or what ln is distributed across, I can basically just group that together. I'll have minus 4 plus 4, that's just going to give me a 0. I'll have 1, so that's just going to give me ln. And then that means I'll only have ln of 4 plus 7. And my final answer here will be this volume right here, pi times ln of 4 plus 7. That's the volume of this shape right here. And that's it.
Don't forget to subscribe to Sam's Education channel and hit the notifications bell to receive regular updates and access to a variety of solved exercises. See you in the next video.